Hello, everyone. Welcome and thank you for listening to our Tech Talk on the power of connected vehicle data with the AWS Connected Mobility Solution. I'm Dean Phillips, Worldwide Tech Leader for Automotive at AWS. I'm based in Detroit and have spent my entire career building automotive solutions for customers with a heavy focus on connected mobility, smart cities, and more recently, autonomous and ADAS development. First, I'll give an intro to what Amazon is doing in automotive. And I'll go over the connected mobility solution, give a demo, and then show you how you can leverage connected vehicle data with our new predictive maintenance solution, Fleet Predict. And once we're finished, and actually throughout, feel free to put your questions in the chat and we'll do our best to answer them. So we're happy to announce and share with you guys that AWS was named Company of the Year Global Automotive Cloud Services Platform for Mobility by Frost & Sullivan. They said AWS demonstrates a clear leadership position in the automotive industry by supporting the entire automotive value chain, including auto tech startups, tier one suppliers, mobility service providers, fleet providers, and OEMs. In addition to that, ABI Research said that Amazon ranks #1 in the connected car cloud platform space. They said we're leading the connected car platform market in both innovation and implementation. And then back in January at the CES conference, VDC awarded us the Embedi Award for Best of Show for IoT automotive services at CES. There are several megatrends driving change in the automotive industry. Electrification mandated connectivity with completely new approaches to vehicle operation. For the first time, bits and bytes have become more important than fossil fuels to make the vehicle move. Battery condition management is the most important thing, especially when you consider it's the most costly component in a vehicle. Autonomous is proving to drive new experiences with robotaxis. Imagine being able to have your car go out and deliver packages for someone or rent it out while you're at work, and then it can bring itself back and drive you home. The rise of mobile and expectations consumers have with software updates, and they want the infotainment experiences to be dynamic. Ownership models are changing, where vehicle subscriptions, experiments from Porsche, Hyundai, Cadillac, and Volvo, and others have proven that people want to own vehicles and use them differently. And of course, all of this is enabled by the agility and economy of scale in cloud computing. So what is Amazon doing as a whole across the board in automotive? So if you look at these challenges, they're not just technology related, they're multifaceted. They require a broad ecosystem of capabilities that are both internal and customer facing. And Amazon is uniquely positioned to help automotive companies deliver this holistic vision and the future of mobility. In our experience, automotives see AWS and Amazon as a strategic partner instead of just a technology supplier. There are 4 major focus areas that we have, or large workloads running on AWS. The first is in the product innovation space with autonomous vehicle development and HPC computing. Toyota Research is one of our reference customers for autonomous, and Nissan announced a project with Rescale for their HPC platform on AWS. When you look at connected mobility, clearly we've got close to 20 million vehicles on AWS by the end of the year. Companies like Ford have moved their entire platform, their connected platform, onto AWS as of last year. Then digital customer engagement for engaging customers with dynamic high fidelity rendered images of vehicles within the vehicle configurators with technology from partners like ZeroLight being deployed with Audi and Cadillac. And then on the manufacturing and supply chain side, companies like Volkswagen are completely overhauling their digital production platform by connecting millions of machines across 125 factories and a supply chain of over 30,000 facilities. And this is with the goal of improving performance, manufacturing performance, by 30% over the next 5 years. So think about the complexity of a vehicle. Vehicles today have a number of different sensors, ECUs, domain controllers, and they're all developed by different suppliers with different operating systems, different methods for updating. Modern vehicles have approximately 100 to 150,000 lines of code. If you look at a battery electric hybrid, the Ford Energy, back in 2015, it was emitting up to 25 gigabytes of data per hour. And then when you fast forward to today with the autonomous vehicles on the road, you find them producing several terabytes of data per hour. When you consider all of this complexity, you have what very much looks like a data center on wheels. When we talk about connected mobility, it means many different things to different audiences. For OEMs, it's about reducing warranty costs, providing new end user experiences, personalization. Mobility service providers want the ability to deploy new and innovative services for their customers. And commercial fleets, it's all about the ability to maximize uptime and drive operational efficiency. So let's take a look at the Connected Mobility Solution from AWS and see how it enables your digital transformation towards smart mobility. So let's take a look at the AWS Connected Mobility Solution. I like to start with describing kind of the three main layers of the solution. First, if you think about the vehicle's producing all of the data, and it has to offload that to the cloud, where you can then start to build all of the engaging experiences that we talked about a minute ago. We want to start to analyze the data, do all the machine learning and the analytics, and then build a collection of APIs or applications, microservices with APIs. And then once you have an API, now you can participate in that ecosystem of mobility applications that you see across the top. You can make a fleet management app, you can connect your mobile devices to your vehicles and your partner applications, and you could have an Amazon package delivered to your vehicle. So once you have the instrumentation, you can then begin to develop those new capabilities. So this is our reference architecture. There's an awful lot of information on this chart, but it's really divided up into logical, functional domains. And so what we'll do is I'll go in and I'll start explaining what the mobility solution is, where we've been and where we're going. So across the top of this page, you can see we've got secure data consumption, driver behavior, anomaly detection, diagnostic alerts, and location-based services. These are all the core capabilities that we released in our Connected Vehicle Solution, as we called it, back in 2017, right around the reInvent timeframe. So since then, we've been developing, as I described at reInvent just this past year, the Connected Mobility Solution, which is an acknowledgement that this is not just about vehicles, but it's about micromobility. It's about helping people get from A to B in different ways. And so we wanted to bring some more capabilities from additional assets we had to give our customers a faster head start and a closer to a production capability by bringing in some technologies from a framework that we developed internally. So I'll talk about provisioning and lifecycle management, developing the IoT things and dealing with the certificates. I'll also talk about software updates and over the air, and then about our new fleet management UI and configuration of the entire system. So let's dive into these use cases. So the first, most basic thing is getting the data off the vehicle, processing it through our IoT core, and then landing it into S3 so that you can begin to build your data lake, make the data available to your data scientists, your product engineers, and all of your marketing and sales domains. So the idea is to, one, we publish the data to different topics over the MQTT protocol. It gets into the IoT core. and through the rules engine, where we can do things like select star from topic A where message value equals Y, something like that. It's a very simple way to process the messages coming from the vehicles through the IoT platform. And then using Kinesis data fire hose, we will push the data into S3. The next thing we do is organize the data into trip records. So as the data comes in from key on to key off, we create a trip record. We put that information into DynamoDB, and you now can go back and look at the historical trips, and I'll display that with the demo later on. And you can then do geospatial analytics and understand where the vehicles are being driven and how they're being driven. Next is driver behavior. With driver behavior, what we're really looking at here is kind of the enablement of the usage-based insurance industry. You know, if we go back several years, insurance companies and their desire to have these scoring mechanisms to rate how a vehicle and how a driver is being driving the vehicle, they helped develop this whole concept of telematics from that perspective. And so once we have the trip record and we have a key off event, we then fire a Lambda function that contains an algorithm that determines some kind of score. In our reference example, we provide a simple calculation to show the driver safety score, but it's an architectural example or pattern for how you can deploy your own very specific and high, to your particular needs, an algorithm that scores either, a safety score for insurance, or you can do any other kind of thing that will evaluate how the vehicle's been driven. So it could be a wearability score. It could be a score on how the fuel economy was affected. It could be a score based on how efficient your usage of the battery is in an electrical vehicle use case. So it's just an example of an architectural pattern you can implement at an event like the key off point in time. Next is a streaming analytics use case. And this is done with our Kinesis Data Analytics service. So as the data is streaming into S3 through Kinesis Data Firehose, on that same stream, we can develop an application in Kinesis Data Analytics where it also uses a SQL-like language to evaluate each message. And within that, we start to build up an anomaly score. So you pick a particular data element and monitor that sensor data coming from the vehicle. And then as it begins to go out of the normal range in its value, you can then fire off an event and determine this is an anomalous data. In our use case, we use the cut forest algorithm to determine the random cut forest algorithm to determine that we've exceeded the index, and then we go ahead and write a record into into Dynamo, and then we send a notification either just to kick off some downstream process. This could be the call center, for example, to call the customer at some point in time to set up a dealer appointment. It could be a notification that goes directly into the vehicle to display something on the dashboard. It could be a use case where you have an Alexa-enabled vehicle and you can prompt the driver to take some sort of action. So again, this is an architectural pattern for implementing streaming analytics in the cloud. You could very easily as well do a streaming analytics use case in the vehicle where you have it deployed in Greengrass, or some other edge runtime as well. So next is around diagnostic alerts. This is, number one, simply a filtering that we can do. As I was describing earlier, how the IoT rules engine works with SQL-like language where you can select from different topics. In this case, we just publish a message from the client in the vehicle when we see DTCs, diagnostic trouble codes, and from there we'll then process that through the rules engine, write a record into Dynamo, and then send a notification. So within the new Connected Mobility Solution, we have some additional components, some of which will go in deeper in future sessions. But in this case, we show an event, a more sophisticated event notification solution. And then we publish everything into Amazon Elasticsearch so that we can enable a responsive user interface in the Fleet Manager, and then continuously build up this index with the vehicle information to support our whole API layer that serves up the user interface. Next is location-based services. So we're just embarking on some new capabilities here, at least a new choice of implementation. So we're going to implement that in a different way in the future. But in our first iteration, we leveraged Lambda and Dynamo, where we would record the geolocation for a particular spot. And then when the vehicle entered that, we would fire off a notification that would either send some kind of a message to the vehicle. A lot of folks like to use this to send marketing offers. It could also kick off some kind of back-end process, downstream process. So it's very flexible in that way. But we're going to work on something different here that we'll bring out in a future release. So those are all existing capabilities. And what I'd like to now talk about are the new features of the Connected Mobility Solution. So first off, we have the challenge of provisioning the IoT things and the certificates that get burned into the vehicle. So what we've developed is an efficient API for the bulk generation of the certificates. And of course, with the IoT core, once we create the IoT thing and generate the certificate, we need to be able to burn these certificates into the telematics control unit at assembly, and put that in with the firmware and the software on the device. We can also support a customized provisioning workflow that's adjusted to your requirements. And then we can support just-in-time registration at final assembly. We can validate that just-in-time registration against an activation list so that we can do the bulk we can support that as one step to say this bundle of devices is authorized for activation, and maybe these bundle of devices are not authorized for activation. And then we have to support, of course, the ability to detect, generate, and rotate expiring security credentials. So these are all some common requirements that, if you start to take the step into actually produce a production capability, these are important and very useful capabilities. So let's dive into this just a bit more to show you how we're using our services to do this. So as the TCUs are made to order and developed, they get registered within the OEM's AWS account. And then the provisioning process starts by a CSR being generated by the TCU's Trusted Platform module as part of the assembly line process. So using the CSR, we create a low privilege device certificate and register it and activate a thing within AWS IoT. Then we store the TCU details, like something like the serial number or the IMEI, within our asset library, which is basically our registry and the back end for the solution. And that sits in a Amazon Neptune graph database. So what do we get from this? We have a low privilege certificate created and loaded into the TCU's trusted platform module. We have a thing that gets registered within AWS IoT. We have a low privilege certificate and policies registered. They're associated and activated within the IoT core. And then a device is created as well inside the asset library. And at this point, you can test the TCU. So just thinking about all of these capabilities, there's a lot of complex steps, and we can customize this process to create sort of an elevated provisioning process so that you can have multiple steps where you can elevate privilege and capability along the way. So once all of the certificates have been generated, now you want to activate the TCU. So during the assembly line process, the TCU gets installed, and then it's activated upon the first key on when it fires up for the first time. And once we do that, we take the vehicle information, capture it, and store it in our device, our asset library. And at this point, it's capable of publishing telemetry over the cellular network. But in this example, we just limit it to be disabled until it's authorized at the next point. Clearly, you could at first key on when the vehicle rolls off the assembly line, you can have it publish telemetry, but it's just not associated to an owner, and so that at least this device is activated and the vehicle is ready to publish all the data from the vehicle into the cloud. And then at this point in time, the assumption is, okay, it's been in transit mode, we get it to the dealership, it's sold, and then we're going to transfer ownership. So the first step involves, a user registering an account with, think of the mobile app that you have, for when you buy a vehicle, you can use the app to unlock the doors and start the car. But you can now register with that. And then we add the user in that case to our asset library, and then we create the Cognito credentials, and now the user can authenticate. Excuse me. Now the new vehicle owner starts the pairing process where they turn on the ignition of the vehicle, and then you get a pairing code where it splashes up on the dash, on the touchscreen in the car. And then you can take that pairing code, enter it into the mobile app, and in the background, we'll go ahead and associate these two. The TCU gets connected, we monitor the device shadow with the low privilege certificate, and then we, if assuming it's whitelist or activated, it's on the activation list, we can then associate it to the owner and the vehicle together. And then we'll do this in the asset library, and we're all set to go. Outcomes from this, we have a user who is registered with the system, an owner who is associated with the vehicle. The TCU has now obtained a high privilege certificate, and it's publishing telemetry with all of its capabilities as you've defined them into the AWS IoT core. Next in the provisioning steps is about certificate rotation. So in this case, when certificates are close to expiration, we'll kick off a job where device management will push out and rotate in a new certificate so that the user experience is not affected. The next capability we talk about is software over the air. So this is, obviously customers are using full-blown software over-the-air solutions from different partners of ours, but we do have some cases where, for heavy equipment manufacturing or maybe micro-mobility, use cases for scooters or e-bikes, or in the case where a customer wants to develop their own. We provide a basic framework in the solution, or we can deliver securely code-signed bundles to the vehicle. We hand it off to a local process where the agent on the vehicle will deliver the package, and then an onboard process will take it and then do what it needs to do to deploy the software, and then pass status back. And then we publish that completion of the job or the status of the job back to the cloud into this connected mobility solution. And from there, you have a basic infrastructure to do this software provisioning. Clearly, we recognize there are partners involved that would do the full end-to-end process. But this helps you get started and helps us start to have the dialogue with our customers to figure out, okay, how are they going to approach this capability? And we leverage the IoT Jobs service to make that happen. And here is a view of the architectural process, the services that are involved to get it done. So we make a call from call an API to schedule a job. We get the update bundle from S3, push it to the device management to then go ahead and manage the process of delivering the bundle. And that can be done over HTTP or HTTPS, or MQTT, excuse me. And then, of course, the last capability is the fleet management UI. In addition to the UI itself, we have a set of capabilities to define within the asset library. You can model your fleet specifically any way that you'd like, geographic, software-based, make, model, type, by component, owner, etc. It's very flexible, uses the graph database to get that done. You find your policy-driven provisioning templates here, and you can model the in-service software BOM to support the over-the-air update process. So you can target multiple domain controllers, if you will, in the vehicle or ECUs. And then, of course, an audit trail of all of that. So for that architecture, we have a typical cloud fronted application that sits on an S3 bucket that we protect with Cognito, and leverages APIs and Lambda before it calls the Elasticsearch service. So next I want to talk to you about Greengrass. Greengrass is software that gets deployed to the edge. Think of it as kind of a self-contained endpoint in the vehicle where you can run Lambda functions, you can push Docker containers. We also have capabilities now where we can stream video and also do brokering if you do micro brokering at the edge, and then of course push ML inference. So Greengrass adds a number of capabilities where you can access local resources like CAN data and the video streams I mentioned. And we can push updates over the air of the Lambda functions and the Docker containers, the inference models. We can also spool the data locally in cases of the cellular connection being gone. And then once connectivity is refreshed, we can then flush that queue and push the data back to the cloud. So it's a very flexible environment that allows you to do a number of things. This is an example where we took Greengrass, we deployed a camera, free RTOS sensor data and telemetry data from a Raspberry Pi. We can publish all that information to Greengrass locally without connectivity to the cloud, and it all functions properly, spools up in Greengrass. We created a driver distraction demonstration where we classified 10 different types of distraction with about 40,000 images so that we could demonstrate how you could use ML inference at the edge and kind of rounds out all the capabilities of Greengrass. We were happy to announce at reInvent our partnership with DENSO and how they're using the connected mobility solution as the foundation for their next-gen offering called the Mobility IoT Core. and service core. So they have two major components, that which is in the vehicle, which is essentially an ECU, a module that accesses CAN data and serves as kind of the gateway from the vehicle to the cloud. They can host partner applications in containers and manage access to vehicle data and resources, and by receiving commands from the cloud. And it's really interesting in how they're planning, because they can deploy multiple applications via multiple containers and do that in a secure way. And this all publishes into the cloud what they call their mobility service core. And this is, the back-end system that's based on the connected mobility solution. So we're really happy to talk about DENSO and what they're doing with AWS. And we demonstrated this at CES back in January. So why don't I switch over to demonstrate the user interface. All right, so here, what I have here is the view of our new fleet user interface. You can see a number of, as I zoom in, you can see on the right-hand side, the list will change as I zoom in. You can see vehicles, clusters of vehicles. I'll zoom out again and show, okay, let's see, we'll move into the Detroit area. And we have fewer vehicles deployed here, and the list on the right kind of shrunk. So as you move around on the map, you can then start to see different, your list on the right will refine. So we'll go ahead and click on a particular vehicle. You can see, the basic information we've captured from the vehicle and from the telemetry perspective. There's trip history for each vehicle. So you can look at the different trip records, as I mentioned earlier, from starting point and end point. We provide some basic information like, excuse me, time, total elapsed time, and miles driven. Another really interesting capability that comes from DENSO's implementation is the concept of video events. So in combination with their partner, DENSO's developed an architecture to capture events that uses CAN data, vehicle data, combined with perception from the camera on the vehicle. And different events like running a stoplight or a stop sign can trigger an event that gets published to the cloud over MQTT. But then once that event happens, they're going to capture plus or minus 10, 20 seconds of video, and then publish that over Kinesis video streams to the back end, and then we'll associate that with, here, as you can see, a set of events. You can click on the event, you can find the event, and then you can actually view it. So in this case, it's just an example of when the car is off in a parking lot, if it detected some interesting behavior outside or suspicious behavior, it'll turn on and then publish a message for that particular event to the cloud and send this data stream. So that's some of the new capabilities in the solution. I'll just show a little bit more. You can also filter by different selections. You can save it, and then you can zoom in on particular areas. So we're happy and excited to share with you this. There'll be more information later on how you can access it. In the meantime, just contact your AWS solution architect or account manager, and then we'd be happy to come do a workshop. So why don't I turn off my screen and our sharing, and I'll go back to the presentation. And from here, we'll start to talk about how can you start to quote unquote, actually, I'll stop here and show you. This is our current existing connected vehicle solution that's online on the solutions website at the link posted. You can take this, deploy it into your account, one click, launches a CloudFormation template, and you can get off and running. There's links to the source code, and you can combine this with our IoT device simulator solution to publish vehicle data into this backend architecture. So this you can start today and get the deployment guide, and then go ahead and get running up and running in your account in just a matter of minutes. So why don't I talk about predictive maintenance? Once we have the data and the platform for your connected solution, how can we start to make use of it in a valuable way? So in this case, we have a fleet situation where, if you look at the cost of fleets, 40% of a vehicle cost can be influenced through prediction. If you look at the life of a vehicle, like a Class 8 truck, they cost about $118,000, but that's only a portion of the total cost of ownership. Its actual total cost of ownership over 15 years is like $2.25 million. So you think of all the operational costs, and for maintaining and operating it, you need to optimize that and identify the areas that you can influence through prediction. So through our analysis, 40% of this around these wearables and around how it affects the safe operation of the vehicle, you can leverage the ability to do prediction. So what we did with our SageMaker team is sat down and started working on what we call Fleet Predict. This is a solution that you can get at GitHub at this link. The idea here is to accelerate your development of a predictive maintenance solution and to reduce the total cost of ownership for doing that. We remove the undifferentiated heavy lifting, for things like the data wrangling and the model development, and then leveraging SageMaker, you can deploy and test. Here is a view of our AWS ML Stack. We're going to focus on the middle here in the SageMaker Studio. These are the tools that we use to develop the solution, where we have the built-in notebook and the parallel training opportunity capabilities in the tool, in the service to develop your predictive models. Well, one of the challenges that our customers talk about is, how do I enable and transform, the skills development with AWS? I don't have hundreds of data scientists. So what we've done is developed a collection of really cool tools and devices. I kind of like to call them toys, because from an architect's perspective, these things are fun to use and to learn on. We have Deep Lens, which is for doing classification, kind of like the hot dog, not hot dog use case, if you're familiar with the TV show. And then you've got the Deep Racer, which allows, is a fully autonomous device. It's like a 1/18 scale toy car, battery operated, that you train to drive itself around a track, and you can compete in competitions in the Deep Racer League using our SageMaker RoboMaker tool and reinforcement learning. So you can learn all of those things with this Deep Racer car. It's really cool. And we now have a new version that I just got myself, and it adds a LiDAR to it. You can get the new kit to add a LiDAR and a second camera. And of course, the Deep Composer, where you can do generative AI to compose music. Just wanted to mention that it's very useful for our customers to kind of get their teams up and running in a way where you can have a lot of fun. So with the Fleet Predict solution, you can get up and running in a day, to build a POC. It can get it aims to get you, started very quickly. If your data is is in a decent format, you understand it quite well, you can get your data extraction. We provide a model to get it, to format it properly, so get it, kind of do the data wrangling and the pre-processing. You can get it, do the training, launch your endpoint, build a quick dashboard, And then really time to value here is accelerated with the solution. So what's the overall process? So most solutions assume that the data is already in the right format, but that's never the case. Most of the time, customers get stuck with this. They can spend weeks and months kind of finding the data and preparing it. There's inconsistent data and missing data. So our solution provides a structured data model for the training. So we give you the data model. We have two basic tables via CSV files, the vehicle information table, and then the sensor table. So if you have the data labeled, you understand it, you can put it into this format, and you can now begin to train a model. So, you take this step, you process your data, you can kick off a parallel GPU-enabled training job in SageMaker, and then get it up and running to a point where you have an endpoint. So once you have the data, the model up and running, you can start to bring in streaming data. And through Lambda function and APIs or the IoT core, you can push messages back out to the endpoint, out to the vehicle, where you can say, hey, there's a failure with, in this case, the battery, for example. But let's dive a little deeper so we can make sense of it. And then once you've done that, you can start to build dashboards to understand the data that you've captured and understand the performance of the model and visualize it. And you can use QuickSight to do that. So what do you get in the solution? You've got a reference architecture, sample data set in that GitHub link. You have a notebook in SageMaker, of course, to do all of this work, and then a CloudFormation template hosted on the GitHub where you can install this entire thing into your account. Makes it very easy to get up and running. So how does this thing work? So basically what you have to do is have the historical data where you've got some failures, and then you'll pull that in from the fleet management system. You put it into S3, and you start to develop your model. Once you have the model, you'll be able to then start sampling the data from the telemetry coming in real time. Persist that into S3 via Kinesis. You can then run the predictions using Lambda on that real-time data coming in over the air from the vehicles, and then persist those predictions in Aurora, and then start to aggregate the results, display them in QuickSight dashboard, send notifications back out to the vehicles or to your call center where you're going to have someone call the driver and say, hey, your battery's going to fail in the next 3 days. So let's have you come in. We'll take a look and swap out the battery. And then that's kind of that's the basic process. Those are the basic building blocks. So for a particular customer we had, they struggled quite a bit at first trying to get the data into the right format. In order for the training to work, we have to have kind of a balanced data sets. So you have to have failure cases and non-failure cases equally. The SageMaker notebook we provide will, as soon as you put it into the format we describe, it will identify the data and balance it out so that you have the same percentage of failures and same percentage of non-failures. And then that will make it so that we can actually get the model trained up. It'll identify 10-minute windows of data where you've had consistent 10-minute, there were no outages, from the vehicle where the cellular connection was gone. So you have 10-minute windows, and then we sample every 30 seconds, and we're able to develop it. Continuously refine that model, and in this example, for this particular customer, We were doing predictions on 68,000 Freightliner trucks, and it was about the the battery in the vehicle, the traditional battery. They were able to get a 78% prediction accuracy on diagnostic errors within 3 days in advance of when they were going to fail. So if you think about a fleet and you have all these trucks, being able to predict that failure to avoid a disruption in the operation of that truck and control when that battery is going to be replaced in those 3 days, it's a massive savings to our customer. So this is an example that we believe you'll be able to adapt to your environment and find similar savings. Here's a reference customer called Keep Trucking, where they help thousands of fleet customers optimize the downtime and the total cost of ownership. They connected their fleet data in the similar way I described from historical data, and then married with live real-time sensor data to build predictive models. So we're happy to help Keep Trucking optimize their predictive maintenance capabilities. So that's a full hour. Thank you very much for your time today. If you have questions, I'd be happy to sit around and answer them. Thank you very much.